Hi class, we are now in our last section of chapter 2. This is 2.4, temperature conversions. So temperature is a measure of how hot or cold an object is compared to another one. The thermometer measures how hot or cold an object is. It's not actually, let's just leave it at that. Measure of how hot or cold an object is. We use a thermometer to determine this. But if we look at a microscopic level, well below a microscopic level, the atoms and molecules that compose matter are in constant random motion. That they contain thermal energy. Thermal is just a fancy word for heat. The temperature of a substance is a measure of its heat energy. So the hotter an object is, the greater the random motion. How does an object become hot? Because the atoms within it vibrate and shake, and when they do, they give off heat. And when something's with a high temperature, that means its atoms and molecules are really moving at a very, very quick motion, and they're giving off intense heat. When something's colder, those atoms and molecules are not moving as much. They're not vibrating as much, and that means that's why it's a colder object. And thermometer simply measures how hot or cold an object is compared to something else. So we're going to look at converting between Celsius and Fahrenheit for the moment. Absolute zero, we'll get to that one later. So if we look at Fahrenheit boils at 212 degrees Fahrenheit, freezes at 32 degrees Fahrenheit. That is a difference, and if you see this arrow over here, that's what this is meaning. It is a difference of 180 degrees Fahrenheit. The Celsius water freezes at 0 and boils at 100. This is a difference of 100 degrees. So this has more intervals in between, and this one has less. So most places in the world use Celsius. We use Fahrenheit. Okay, so in order, you can see this one has more intervals in between. This one has less. So there's less space. This has less space between, where this one has more space. How do you convert? Well, if you want to know the Fahrenheit, then you have 9 over 5, and you take your Celsius degree temperature and you multiply it. You multiply it either by 9 and then divide by 5. You can figure this part out. You've had algebra. Plus 32. Now, I tend to remember this one, which is 1.8 times the Celsius temperature plus 32. And that will solve for Fahrenheit. But I want to give you what's in your book. Now, to get Celsius, you simply flip this and minus the Fahrenheit temperature by 32, and then you flip it. You multiply by 5, divide by 9, it gives you Celsius. I tend to use this one and then just isolate for Celsius and move everything around. So your book gives you this, your book gives you this. This is what I use. That's all I'm going to say about that. Okay, 3 temperature scales. We have Fahrenheit, Celsius, and Kelvin. Kelvin is another temperature that we use. There are no negative numbers. The lowest absolute temperature that has ever been recorded or investigated, experimented, whatever you want to say, is 0 degrees Kelvin. That means absolute zero. So when you hear the word absolute used, it refers to Kelvin. We're not there yet. Once we will use it in gases and other things, but at this chapter, you're going to learn how to get to it. So what's the difference? Well, we start out with 0. 32 degrees Fahrenheit for freezing point, 0 degrees Celsius, and for Kelvin, it is 273 Kelvin. For boiling water, it's 212 degrees Fahrenheit, 100 degrees Celsius, or 373 Kelvin. So there's a difference of 100 degrees here, there's a difference of 100 degrees here, and there's a difference of 180 here. So you can see the increments here are matching to somewhat where these are not. So the lowest absolute temperature is 0 Kelvin, negative 273 degrees Celsius, or negative 460 degrees Fahrenheit. There's reasons why we use Celsius and Kelvin. They're just a lot easier to use in chemistry too. Okay, so how do we get to Kelvin? I've just showed you the conversions for Celsius and Fahrenheit. It's very simple. To get to Kelvin, you get to Celsius. Once you get to Celsius, you add 273 degrees. Let me start over. 273.15 to your Celsius, and that will give you Kelvin. So in this case, you would add, let's say you had 0 degrees Celsius, then your Kelvin would be 273.15. You have to get out of Fahrenheit, you go to Celsius, then from Celsius you get to Kelvin, because you can add 273. If you need Celsius, you need to get to Celsius from Kelvin, you minus 273.15 degrees, and then you can go on to Fahrenheit. So Fahrenheit, it assigns 0 degrees Fahrenheit to the freezing point of a concentrated water solution. That is not right. Where did that come from? Oh, maybe that's how it assigns it. 96 degrees Fahrenheit to normal body temperature. Ignore this sentence. I don't know where that came from. I don't like it. On Fahrenheit, water freezes at 32. This sounds more like it. And water boils at 212. Room temperature is approximately 72 degrees Fahrenheit. For Celsius and Kelvin, Celsius water freezes at 0, boils at 100, and room temperature is approximately 22 degrees Celsius. For Kelvin, voids negative temperatures altogether. So we assign the lowest absolute possible temperature. Its absolute 0 is 0 degrees Kelvin, capital K. Absolute 0 is the temperature at which molecular motion virtually stops. Water freezes at 273.15 Kelvin, boils at 373.15, and room temperature is approximately 295.15 Kelvin. Okay, so let's, again, these are slides from another course because I did not have your homework. I'm just going to keep repeating that because I couldn't see it. What is the temperature at which water freezes? So if we look at those, you might say, well, all of them. But let's take a look. If we go to where water freezes, do we have a 273 up there? No. Do we have a 0 degrees Celsius? Yes, we do. And we have a 0 degrees Fahrenheit, which does not happen. So it's going to be this one right here. At which temperature does water boil? So let's go to water boils. Do we have a 373 Kelvin? Yes, we do. Does water boil at 32 degrees Fahrenheit? No, it does not. And does water boil at 100 degrees Fahrenheit? No, it doesn't. So this one's going to be this one. How many Celsius units are between the boiling and freezing points of water? That is 100. So this is 100 water boils, 0 is freezing point, so it's going to be 100. So here's in bold, you can see our answers. This just is to help familiarize yourself with these different temperature conversions. Okay, so a refrigerator maintains an inside temperature of 40 degrees Fahrenheit. Express this temperature in Celsius and in Kelvins. So it's going to do two things. You need to get it in Celsius, and once you get into Celsius, you can then convert it to Kelvin. So we're going to use the 5x9 that your book gives you, and let's plug in the number. So where it says Fahrenheit, we plug in 42 degrees minus 32, so that's going to give us 10. Then we're going to multiply by 5 and divide by 9. That will give us 5.6 degrees Celsius. Now I want to point out something. This is 2 sig figs. This is 2 sig figs. This is exact, and this is exact. We do not count these in our sig figs. So our answer is 5.6 degrees Celsius. Now, we need to add it to Kelvin, a 273.15. Subtraction and addition rules now apply. Line up the decimals, which is not shown here, but the digit with the smallest decimal digits next to the decimal point is 5.6 in the tenths place. So that means that we don't need the hundredths place. This is going to get kicked out, and our answer is going to be 2.78.8 degrees Kelvin, or 278.8 Kelvin. Sorry, there's no degrees. So when you have to do addition and subtraction, the same rules apply. This is not lined up because now we're past that. You should understand that you line up the decimals and then take the digits with the value with the smallest amount of digits next to the decimal point. Okay, I'm going to use something from another book. This is where the 1.8 comes from. Adjusting for the different freezing points of 0 and 30 degrees Fahrenheit, we can write temperature equations to convert between Fahrenheit and Celsius temperatures. So this is 1.8. This is equivalent to the 9.5, not 5.9. If you enter this into a calculator, you will see that number is 0.555555 and it goes on forever. 9.5, if you plug this into a calculator, you'll get 1.8. So this will help change from Celsius to Fahrenheit. And then this 32 adjusts for the difference in increments. That's what you're seeing here. Okay, so we have it here, and if you needed to adjust it over, this is showing you to simply isolate for Celsius. So if you start with Fahrenheit, how do you get this to Celsius? Well, you subtract the 32, so we move this on both sides. So this is Fahrenheit temperature minus 32. And how do you do that? Well, you subtract on both sides. You minus 32, minus 32. So that cancels that out. Now we can divide by 1.8. That brings it over here. So we divide this side by 1.8, this side by 1.8. This canceled out. And now this gives you Celsius temperature. I tend to like the 1.8 easier than using the 9/5 and the 5/9, but that's just me. Okay. So this is showing you how to move it around if you didn't want to use the 9.5 and 5.5/9. But your book gives you that, so that's why I've included it in here. Okay, a person with hypothermia has a body temperature of 34.8 Celsius. What is that temperature in degrees Fahrenheit? So we need to state the given and needed quantities, write a temperature equation, substitute in the known values, and calculate the new temperature. So what do we have? We are given 34.8 degrees Celsius. We need the temperature in Fahrenheit, and we need a temperature equation. So here's our temperature equation. I'm going to use the 1.8 times the Celsius temperature plus 32, and that will give us our temperature in Fahrenheit. So now let's plug everything in. So from here, we have our 1.8. We multiply it by 34.8 degrees. That is going to give us 62.6 plus 32. Our answer is 94.6 degrees. Now, why is that when there's only 2 here? Because the 1.8 and the 32 are exact. This should say are, not is. Are exact, so we do not count their sig figs. So we're only going off of this one here, and that is 94.6, 3 sig figs. Digit is in the 10th place. That works. On a cold winter day, the temperature is negative 15 degrees Fahrenheit. What is the temperature in degrees Celsius? So let's take a look. So we're going to use this equation. Remember, 32 and 1.8 are exact. Finally, I did the right R there. Now we're going to plug this in because we've isolated. On the previous slide, I showed you how to isolate and move this around to solve for Celsius. And then we're going to use that equation. So from here, we do the negative 15 minus the 32. Where am I? If you get confused, look at this one here. The one that shows how to, you're going to plug the Fahrenheit in here. So in this one, we have negative 15 minus 32. That gives us negative 47. We divide that by 1.8, and this gives us an answer of negative 26 degrees Celsius. This is in the ones place. We have 2 sig figs, so that ends up in the ones place, and that answer would be D. What is the normal body temperature? 37 degrees Celsius in Kelvin. Kelvin and Celsius is the easy one. All you do is line up the decimal points. In this case, this doesn't have a decimal point, so you'd write 37 here. And what does that mean then? With addition and subtractions, we are interested in the value that has the least numbers closest to the decimal. This one does not have numbers on the other side of the decimal, so you're going to do a line and cut it off. And because we're going to cut it off, that's why you see this value here. This has been cut off because there is no numbers on the other side of a decimal point for this 37. So this means that 37 degrees Celsius is equivalent to 310 degrees Kelvin.